Yo, what's up guys? So today we're going to be talking about the aminoglycoside question that we got in kinetics today. And basically there's a lot of confusion about the time. So what I'm talking about is when you have the shorter fusion equation, which we know is, the whole mess, whatever, blah, 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 blah. There's an e to the negative kt in there somewhere. And a lot of people are confused about what is t exactly. So that's what we're going to go over. The main thing that I want to talk about in this video is just going over how to find the peak, how to find the trough, and how to find the trough using the shortcut. And by shortcut, I mean this equation that he used, that Dr. Hughes used. So, and these two equations would be with short infusion, which is abbreviated SI. So, without delaying, we're just going to jump right into it. So, I'm a visual learner, and I basically like to draw out everything to help me understand. So, using everything given in this question, and the most important thing being Q8 hours. So, if I were to give this drug at 1 p.m., aminoglycoside, gentamicin, at 1 p.m., the next dose, it would be separated by 8 hours. So, the next dose would be at 9 p.m. Okay, we know that. We also know with gentamicin or aminoglycosides in general, you have to infuse it, and in this case, it's a 30-minute infusion to reach the top, right, the max concentration. So this max concentration would, number one, occur at 130. These are just made up values, by the way, but yeah, it would be infused up, and it would hit the peak concentration at 130. So it's important to keep this number in mind because to keep this point in mind because it's not really the point that we measure for the blood level. We know that with aminoglycosides, you want to wait another additional 30 minutes for it to distribute. So at 2 p.m. is when we're actually going to draw the aminoglycoside level. So by 2 p.m. it's not going to stay at this concentration, right? It's going to distribute a little, and it'll probably be here. So now this is I'm going to label this the real peak, or you could call it the expected peak. And I'm going to label this as the fake peak, which we're going to use as a benchmark. It's important to make this benchmark because if you don't know where your starting point is, it's just going to be confusing later on. So number one, how to find the peak, which is easy. So all you do is you can ignore everything else in the short infusion equation and just focus on e to the negative kt and what really goes in this t position. Well, we know that t is going to be how much time has elapsed since the beginning, right, or since whatever we're measuring. So because I use this point as a benchmark, we don't even know what this value is actually. It could be whatever x concentration, milligrams per liter. We don't know what it is, but all we know is that it's a benchmark for us. So at 130 the concentration is this, and at 2 p.m. is the real peak concentration. So how much time has elapsed? Well, that's easy. 1:30 to 2 o'clock is simply 30 minutes, or 0.5 hours. So number one, in order to find the peak, you get 0.5 hours as the t. And if you plug everything in, this should be equal to 6.6 milligrams per liter, using t as 0.5. For the second point, so in order to find the trough, we have to look at e to the negative kt again because this is in our equation. And what is the t in the case of the trough? Well, if I were to draw, the decay down all the way to 9 p.m., this is where we would take the trough. So now we look at our benchmark, which is at 1:30. How much time has elapsed from 1:30 to 9 p.m.? And that's easy because it's 7.5 hours. So in this case, t is equal to 7.5 hours, and if you plug it in, you should get a trough of I believe it's 0.59 milligrams per liter. Okay, now Hughes wanted us to do the shortcut method, which was simply using CO times e to the negative kt. And the reason why everyone got confused was because t in this case was no longer 7.5 hours, t was 7 hours, and everyone's asking, oh, why is it 7 hours instead of 7.5? Well, the reason is because CO in this case is no longer this fake peak benchmark. CO, the reason actually why we can't use the fake peak benchmark in this third scenario is because we don't really know the value. So we can't really set CO as a value. It's unknown. So we change it to, from the fake peak to the real peak. So this is the value we use, and we already have the real peak calculated, which is 6.6. Now if you do 6.6, which is at 2 p.m., we know the real peak 6.6 is measured at 2 p.m. How long does it take to get to 2 p.m. to 9 p.m.? And that is 7 hours. So there you have it. Ultimately, a way to check that you did this correctly is if finding the trough through the shortcut is equal to the trough using the actual short infusion equation, and they should both end up with 0.59 milligrams per liter. So yeah, that's pretty much it. Peace. I'm out.